we're going to figure it out, we're going to learn it, and then it has to be memorized, okay? So any remaining questions that you have, ask them in the chat. Anything you know, say it out loud, put it in the chat. We'll work together to piece it all together. So starting with number 1, what should I be doing first with number 1?
Distributing the -2.
Good. So this exponent on the outside has to be distributed to every part of the inside. So it gets distributed to the 2, as well as the x, as well as the y. So what happens is the 2 doesn't have an exponent to begin with, so we can just give it the -2. So I have 2 to the power of -2. Then I have x. What happens to my x? My x already had a 3. So what do I do between the 3 and the -2?
You multiply 3 times -2 to get your new exponent.
Good, we get -6. Negative times a positive is a negative. And then similarly with the y, we got to multiply first. Well, what's -3 times -2?
6.
Good, +6. +6. Okay, so we're here now. And at this point, and we're going to see this in the next few examples, but anytime you have a negative exponent, something's going to flip, okay? Things that are negative, wherever they are, they're going to go either down into the denominator, or if they're already in the denominator, they're going to go up to the numerator, okay? So which of these values has to move? Which one has to go down?
The -6.
So x with the -6, and there's another.
2 with a -2.
The 2 with the -2, exactly. These two guys right here have to go to the denominator. Whereas the y can stay exactly where it is, it's going to stay on top. So now I have y to the power of 6 over 2 to the power of 2 and x to the power of 6. Remember that once it moves, once it goes down to the denominator, those exponents can now be positive. You've kind of eliminated that negative sign, and now they can be positive. So now there's just one last step, which is that we have a number that we can actually evaluate. 2 squared, what does that give me?
4.
Is 4. So I have y to the power of 6 over 4x to the power of 6. And that is all that I can do. I can't do anything else because you would need to have kind of like terms in order to combine anything else, and I don't have any like terms anymore. I have a y on top, I have an x on the bottom. They are not like terms, so I can't simplify or do anything else with them.
Wait, what about, wouldn't it be 4x?
Well, yes, it is 4x, but that's already as simplified as I can make it.
Oh, okay.
Okay. So this one was actually, I think I want to come back to this question. So if you have any questions about it, if you're a little unsure about what I did, I would like to come back to it because I think that number 2, 3, 4, and number 5 might help to clarify any couple of questions you might have. So I want to go ahead and move on to number 2. Now remember what I said. What do negative exponents sort of make you do?
Divide.
Kind of, but on a more basic level, if you have a negative exponent, where do you go?
In the denominator. Right.
So usually you go down into the denominator, but what happens if you're already there? So for example, here I have a negative exponent and it's already in the denominator. Where is that going to go?
You said
numerator.
It flips so it's a numerator.
Yeah.
You flip it.
You flip it. So now this whole thing can come up. So I kind of like to think about it like it's like a ticket. Like that negative is like your little ticket. What happens when you get on a bus? You give them your ticket and then they take it and it's gone. So what's going to happen is it's like a ticket. It's going to ride up the elevator to the top floor now. So it flips. So this is 2 to the power of positive 4 over 1. It flips. But what's true about something over 1? When something is over 1, do I really need to write that 1 in the denominator?
No.
No. So I can just leave this as 2 to the power of 4, positive 4. And then since that's an actual number, I can do that math. Let's actually do it. What is 2 to the power of 4?
16.
16. 2 times 2 is 4, times 2 is 8, times 2 is 16. So we end up with a nice whole number 16. Questions on number 2? Okay. I'm going to skip around a little bit. Let's go to number 5 because number 5 is kind of the opposite. In number 5, there is no denominator, but you can kind of think about this as 7 to the power of negative 2 over 1. So what happens to this number? Where does it go?
You have
The
to flip it to the
denominator.
denominator.
Yeah, flip it down to the denominator. So this becomes 1 over 7 squared. And what is 7 to the power of 2?
49.
14.
Ooh, 7,
14.
It's 49 because it's 7 times 7.
49. Remember that exponents are repeated multiplication. So it's not telling me to do 7 times 2, it's telling me to do 7 times 7 times itself. So I get 1 over 49. So number 2 and number 3 are kind of like opposites of one another. Do I have any questions on those two? And remember, right now is your chance. So even if you're not sure what your question is, just tell me if you're confused at this point or having issues or having troubles.
I don't understand how number 4, how number 3 and number 4 would work.
Okay, that's good. So I'll go over those next. But any issues with number 1, number 2, or number 5, the ones that we have done already? Okay, cool. So let's take a look at number 3. Number 3 has a couple of different things going on. First of all, is there going to be any number or variable that will flip to the numerator or flip down to the denominator?
For number 3, are we doing number 3?
Number 3.
You would flip the 13 and with 13x because it's a net. The exponent is -7.
Good. The exponent is a negative number. It's a -7. However, be very careful. The -7 belongs with the x, but it does not belong with the 13. Okay? So exponents in general, they don't cross over. They don't apply to other numbers unless there's parentheses. But since the 13 is separate from the x, there's no parentheses involved, that -7 only belongs to the x. It does not belong to the 13. Therefore, only the x that's on the bottom, that x is going to flip up to the top. So I'm going to go ahead and write that. Oh. Hold up, guys. My pencil is out of battery, I think. So give me just a moment. I'm going to charge it. But I can draw. Let me draw on this on Zoom. So yeah, so this -7 tells me to flip just the x. So just the x is going to come up to the top. Okay, so what does that leave me with? Now I have 52.
52 x exponent is 7.
And what about the one? What about the one that was already there? Is that one moving or going anywhere?
It's flipping onto the bottom.
The 6, is that one negative?
No, it's positive, so they're being added.
Good.
But Miss, right? If you flip it, it's gonna have to turn to a negative.
Right. So because the 6 is positive, we're just going to leave it where it is. We're not going to flip it because that would not be what the rules are. So we're just going to leave that one where it is. This one is now positive. Yep. Once you flip it, it becomes positive. And then I'm left with just this 13 down at the bottom. And then, Chris, you said we're going to add them now, right?
Yes.
Because I have a 6, I have a 7, and they're matching. They have the same base. They both belong to an x. So since they have the same base, we can add them together. 6 plus 7
13.
is 13. So I have 52 x to the power of 13. We just added those together. Ooh, that was so messy. I'm doing this on my keyboard, on my mouse, so it's a little hard. And then I have 13 in the denominator. Now, is there any other way to simplify this? Can I do any more math at all to simplify?
Can you divide 52 by 13?
Yeah, you sure can. And that we're just going to treat that like any normal type of fraction. So what is 52 divided by 13?
4.
Is 4. So all I have to do now is we're just simplifying, really. We're just dividing that because we can. If you're able to simplify something, then you should. That's kind of how it goes. So then I end up with 4x to the power of 13. That's it. Okay, so any questions on that one, number 3?
I have a question, Miss. So when I worked this one out, I got that answer, but I didn't do it that way.
How did you do it?
I just divided first,
Mhm.
and then I did 6 minus -7.
Yeah,
But
the way you did it is exactly the same thing that we did. You just didn't know it, because when you do 6 minus -7, 6 minus -7, what operation are you actually going to do?
You just
Add.
You're just adding. And what did we do here?
You added.
We added there as well. So it's the same exact thing. We're following the same exact rules, just kind of talking about them in a different way. So you were right in the end.
Okay, that makes sense. So could you do that every time, or was it just this time?
You can do that
Oh.
every single time. In fact, let's do number 4, and we'll have to do that for number 4. So in number 4, very similar situation, right? You've got x's on the top and the bottom, and since we have matching variables, we are able to subtract those two numbers. So, and this is where you have to just be a little bit careful, because I have a 5 and a 2. Am I doing 5 minus 2 or 2 minus 5?
5 minus 2.
5 minus
5 minus 2, top minus bottom. So we can do that. And then what else can I do to simplify that?
Divide the 8 by 4.
Divided by 8 by 4, and it would be 2x3.
Good. So since I can also divide, let's just do that all in one. I can divide 8 divided by 4 gives me 2. 5 minus 2 is 3. So just like Chris said, this is going to be 2x to the power of 3. So I'm going to pause there. Are there any questions on number 3 or number 4?
Why did we begin to why did we start by dividing the exponents first?
In number 4?
Yeah.
So in number 4, I kind of did 2 steps in one. I kind of did 2 things all at once, because I noticed that I can simplify the coefficients. So I can do 8 divided by 4, and I can do 5 minus 2. And I could split those up and do those in 2 separate steps, but at this point, we can kind of do those 2 things in one step.
Thank you.
Any other questions? Cool. I'm going to pause there. I think I have to stop sharing so that I can like my Apple Pencil is not pairing with my iPad for some reason. So I need to stop sharing and then I'll put it back on the screen in just a moment. So give me a second. Technology. It's supposed to help, and then it just makes life more complicated sometimes. Let me see if that worked. Yes, okay. Alrighty. So unfortunately the answers went away, but I'll write them down again. So this one was 4x to the power of 13. And then number 4 was 2x
To the power of 3.
Perfect. All right. Okay, so that leaves me with just the last one, number 6. Number 6, this one's fun. So negative 9x to the power of 0. What do we know about the power of 0?
Would it be multiplying by 0?
Nope.
Would it be just negative 9x?
Don't you?
Stays the same?
Wouldn't it give you 1? Anything to the power of 0?
There it is. Anything in the world to the power of 0. Anything. 1 million, 1 billion to the power of 0 is 1. However, there's something else going on in this question that kind of messes it up because I have a negative symbol, right? Now, that negative symbol is in a very important place. It's outside of the parentheses. So let's just think about what the rules are telling me. The rules of exponents tell me that, in theory, technically, what I need to do is I need to take that 0 and I need to distribute it, right? But when I distribute it, since that negative sign is outside of the parentheses, I'm not touching it right now, because right now I'm just applying my 0 to the inside of the parentheses. So I'm just going to leave that negative out where it is. And now I have 9 to the power of 0, and I have x to the power of 0. And like Daniela just said, anything to the power of 0 is just going to give me 1. But remember, that negative, we haven't touched it yet. So this is 1 times 1. 1 times 1 is 1.
Wait, it counts the variables too?
Oh yeah, anything. Remember what I said, anything, no matter what x is, no matter what y is, z, x, q, r, whatever, if it's going to the power of 0, it's automatically 1. Okay, so for that reason, 1 times 1 is 1, but I have a negative sign on the outside. So my final answer is negative 1. And that's something that's going to be super important. The placement of the negative sign is going to change the answer. So what I want to actually do is I want to do a quick example. I'm just using this for the blank space, so ignore what it says. But just a quick example. Let's say I have okay. So they look very similar, but the placement of that negative symbol is different, okay? So I just want to show you what that does. In example A, we distribute the 0, same as before. This would be 3 to the power of 0 and x to the power of 0. 3 to the power of 0 is
1 and
x to the power of 0.
1.
1 times 1.
1.
1. So this one's just 1. What about B though? B, now I've got negative 3 to the power of 0. What's negative 3 to the power of 0?
1.
Yeah, it's just 1. Because remember, anything to the power of 0 is 1. Even if it's negative, even if it's positive, negative, decimals, fractions, imaginary numbers, rational numbers, which you guys don't even know about yet. Any number to the power of 0 is 1.
Wait, there are imaginary numbers?
There are. You gotta look under your bed for them because they might pop out of nowhere.
I know there are rational numbers and irrational, but imaginary?
Mhm.
What do you like write random symbols and bang? This is 34 or like 302,000.
You will learn about imaginary numbers in Algebra 2. So for now, you can pretend they don't exist. They're not gonna haunt you in your sleep until you get to high school. Okay, and then in example C, kind of like I was explaining, since the negative symbol is outside of the parentheses, that changes things. Because now I still get 1 on the inside, but that negative sign on the outside doesn't get applied until the very end. So
So similar to the other problem, it's going to be -1.
-1, exactly. So questions, let me go back. Questions on any of these 6 problems. These are very important that you guys understand how to do them. So at this point, if you don't know like where I got the 6 from, where I got that 13, just ask me in the chat. Just let me know so that I can explain it a little bit better if you need me to.
Miss, I have a question. It kind of applies to all of them. So if you ever have a negative in the bottom, it'll always go to the top no matter what.
Yeah, because
Okay.
the thing is that negative exponents, like they kind of like don't make sense, right? Because what is an exponent? An exponent is repeated multiplication, right? So 2 to the power of 4, 2 times 2 times 2 times 2. That's what it means. But then when you have a negative exponent, it kind of like messes that up, right? Like it's kind of hard to think about how would you multiply something by itself a negative amount of times. So that's why if you ever see a negative exponent, you don't want it to exist. You want to move it to where it belongs so that that negative symbol can go away. So when I tell you to simplify something or evaluate or give me an answer, I'm basically telling you, I see a negative there. I don't want it there. I want you to move it to where it belongs and then give me the final answer after that. Okay.
Okay, that makes more sense because yesterday when I was doing the homework, I kept leaving it in the bottom and I was so confused as to why I kept getting it wrong.
That's why. Because when something is the most simplified as possible, there shouldn't be any negatives left over. Okay. I'm getting a request to do number 1 one more time. So I will do number 1 again. And then we'll move on to what we're actually learning today. So in number 1, first things first, since there's an exponent on the outside, you have to distribute it into the inside. That is one of the rules that you guys wrote down on Thursday and that you practiced on Friday. So exponent on the outside, we multiply it into the inside, which leaves me with 2. Oh, not again. Guys, my pencil is like on 0% battery at this point, which is why it keeps dying. But let me plug it into, hold on. I see my issue. Okay. So I'm gonna do this without my pencil one more time. My bad.
Miss, why do you have an electronic pencil? Just use a regular one.
Because this app, the one that I'm using, doesn't actually work without an Apple Pencil because, again, technology. But I mean, luckily I had an Apple Pencil, but I can't just use a regular one.
Well, why don't you buy a stylus?
But like I can't use a stylus on, even if I try with my finger, like right now on the screen, I'm trying to type or write on it, but it doesn't, it just moves.
Oh, okay.
Yeah. Okay. So again, I'm multiplying. So I end up with 2 to the power of -2. So everything gets a -2. This is just like distribution. Then x to the power of -6, because 2 times -3 is -6. And then y to the power of +6. So any questions just on that part, on the distribution?
What are those? Oh, those. Okay, never mind. I thought that was a B.
No, that's a 6. I'm sorry. It's hard to type, to write. Okay. Well, then, like we were just saying, things are not simplified until the negatives go away. So when I see a negative, I know that either it's going to go down or it's going to go up, depending on where it is. And since those are all in the numerator right now, right, this is over 1. When something's just a whole number, not a fraction, it's over 1. So the 2 to the power of negative 2 and the x to the power of negative 6, they're going to pop down under to the denominator. So I'm going to do that. The y stays where it is. So I get y to the power of 6 over 2 to the power of 2, and then x to the power of 6. They're now positive because they are where they're where they belong. They belong in the denominator. The negative goes away. Questions up to that point?
No.
Okay. And then the last step was just doing this right here, 2 squared. 2 to the power of 2 is 4. You can actually do that. So we write that down. So I get y to the power of 6 over 4 times x to the power of 6. Okay. Questions on that? Any remaining questions on any of these problems?
No.
No. All right. Cool. So like I said before, I wanted to take as much time as we needed to just go over this one last time because now we're moving on. And if you're still having any troubles with exponents, things are going to get a little bit tougher. So it's super important that you guys understand what I would say are more so the basics. That way, when it gets a little tougher, things won't be quite as hard. But as we go through today's lesson or anytime, please speak up if you need help. Please let me know if you need an extra explanation. I'm happy to do that. I want to make sure that we're understanding as we go. Okay, let me clear. Hold on. So what we're actually going to be talking about today is what we call radicals. Does anybody know what another word for radical is?
Rad.
No. You've seen it before. You probably just didn't know what it was called.
Square root.
Yeah, square roots. So radicals, a radical symbol is this one, the one that looks like this. It's the same thing as the square root symbol. So what I want to do today to start off with is just kind of do a quick review of what is a square root, how do we figure out the square root of a number, and then go from there. So first things first, I'm going to write down some pretty easy problems. I want you guys, if you know the answer to it, to fill it in using the annotation tool. So you can fill it in as soon as you have the answer. I guarantee you guys will know what this is. Good, I'm already seeing some answers up. Keep them coming. Chris just wants to do all of them.
Oh, miss, that 5.
Now you see what I was like trying to write it with my mouse. It's not easy.
Miss, you did it really neat. I don't know how you did that.
Okay, so you guys are getting pretty much the ones that most people know off the top of their heads. The remaining ones, you might not know them, but you can always do it on your calculator real quick if you don't know.
I don't have a calculator.
Well, then do it by hand. 15 times 15, let's go. Okay, so there's my list. Oh, I think it's not 255, it's 225. 15 times 15.
Oh yeah, miss.
It's okay. These are numbers that we call perfect squares. Perfect squares. So the values that we got as the answers, all of those numbers that you got as the answers, those are your perfect squares. 4, 9. Hold up, what is 4 squared?
16.
16. Can we fix that one, please? So 4, 9, 16, 25. Not 12. What should that one be?
36.
36, 49, 64, 81, 100, 121, 144. And then I skipped 13 and 14, and then 16 and 17, and 18 and 19, because they're not quite as necessary to memorize, but 15 squared and 20 squared, those are also kind of numbers that you should just know off the top of your head. So most of these you guys already knew, right? 3 squared, 4 squared, 5 squared. You guys probably already knew those. 8 squared, 9 squared. But the bigger numbers, 11, 12, 15, and 20, make sure you also have those memorized, because just by knowing these off the top of your head, you're going to save yourself a lot of work down the road. Like Chris was saying, he doesn't have a calculator. You would have to do it by hand otherwise on a test. So these are numbers that you should have memorized. And if you don't, then go ahead and just take a moment to write them down. Okay. Now, the square root or the radical, oops, sorry, disconnected a little bit. Is it going to come back? Yes, it is. Okay. The square root or the radical is what would be the inverse or the opposite of putting things to the power of 2. So you know how everything in math always has opposites, right? What's the opposite of addition?
Subtraction.
Subtraction. What is the opposite of multiplication?
Division.
Division. And what is the opposite of going to the power of 2?
Going negative. Going to square root. Square
root, exactly. So the square root is just the opposite of the power of 2. Okay. So what I'm going to do now, I'm not going to erase what we've got, but I am going to write on the other side. Now we're going to do the square root of things. And you're going to see it's the same exact numbers, just kind of working backwards. So the square root of 4, the square root of 9, square root of 16, and you can fill these in as you go. Square root of 25, the square root of 36, Good, fill them in, guys. Use that button. By the way, can somebody explain where to find the annotation button for those who might not know where it's located?
When somebody starts sharing their screen, you will see on the top of your screen, you are viewing, in this case, Miss Lopez's screen. So you press view option, and then you'll have a drop down bar, and then there you'll see zoom ratio, annotate.
And it's that button, right? The annotate button. Thank you, Chris.
No problem.
All right, so go ahead and fill in these answers. It should be pretty easy because we have the answers right there in front of us, but that is what the square root is. It's just the opposite of bringing something to the power of 2.
Miss, technically, you would be able to write 2, right? Just 2 all the way.
What do you mean all the way?
All the way down, you can write 2, because if you write 3 on the little balcony.
Oh, I see what you mean. Yeah, that's a really good point. So the square root symbol, the radical symbol, technically has a little 2 sitting on the I like that, the balcony. That's cute.
Thank you.
Yeah. It's just that when you don't see it there, you can assume that we're talking about the square root. And then sometimes there will be a number there, and we'll talk about that in just a moment.
Miss, I have a question about the list on the left.
Okay.
So, why did you write like 13 to the second power, 14 to the second power? Like, why did you go from 12 to 15?
So because the ones that I have on the screen are the ones that you should just kind of know off the top of your head. 13, 14, 17, 18, and 19 don't come up that often. So that's why I didn't really write them down. But if you want to memorize them, that's also, going to help you out. So if you just feel like memorizing those as well, go for it. And if anyone wants to write them in at this moment, you can do so as well. In fact, what is 13 squared?
169.
Yeah, 169. And then 14 squared?
Wouldn't you be
196.
196, yeah. So those are actually kind of easy to memorize because 169 and then 196, they kind of have a little pattern. What were you going to say, Chris?
Oh, I thought it would be minus 11, or in this case, or 22.
For which one?
For I thought that would be the difference between 15 squared and 14 squared.
Oh, yeah, no. It's more than that, right? Yeah. Okay, so questions so far on square roots, because now I'm going to talk about cube roots, which that was one of the options for yesterday's assignment. So some of you did it and that was great, but I saw that some people skipped that one or like they got a low score on it. So I definitely want to go over that. Okay, I'm going to go ahead and clear. So that's square roots. Now, if the square root is the opposite of bringing things to the power of 2, what do you think the cube root is going to be?
Bringing things.
Bringing things down by the power of 2.
So it's actually not going to be the power of 2. What is it going to be?
Power of 3.
Power of 3.
Yeah, power of 3, exactly. Now for these, there's not as many that you should have memorized, but there's some that you definitely want to have like in your head. So 2 to the power of 3, 3 to the power of 3, 4, 5, and 10. The rest don't come up that often. So the reason, it's not that you shouldn't know what they are, but you don't really need to have them memorized like in the back of your head. So go ahead and fill in those. 2 to the power of 3. Good. Good. 8, 27. What's 4 to the power of 3? $125, 1,000. Good. And then we're just missing 1. 4 to the power of 3. Try it out. Do it on your count. 4 times 4 times 4. What do you got?
It's 64.
64.
That's so bad.
Where'd you get 256 from? You went too many times. 64 is our answer. Oh, I'm sorry. I just deleted the wrong one. Oh, no. Sorry. That should be a 64. Oh, there you go, Zakaya. Thank you.
Oh, miss, I thought it was 4 times.
Yeah, you went one more. All right, so good. It's 64.
Wait. It's 8. It would be 8 times 4 then, though, right?
8 times 4? No. Oh,
Yes.
no,
Yeah,
no,
4
because
times
4, because it's 4 times 4 times 4.
Oh, 16.
So it's
Yeah, I would have
16
never gotten
times
it.
4. Okay.
Oh, wait. I actually thought from 2 to the power of 3. I actually thought it was 9. It's 2 times 2, which is 4, and then times 2 is 8.
Yeah, so be very careful. So remember, it's all about repeating multiplication. So now on the flip side of that, we can do the cube root, which is just the opposite. So the cube root, and see how there's a little 3 there on the ledge on the balcony? That tells you that you're taking the cube root. So I'm going to write that down. The cube root of 8, the cube root of 27, the cube root of 64, 125, and 1,000. Good.
Everybody did.
Everyone's getting in
That's
there,
a
yeah.
lot of 5.
Now careful, the cube root of 1,000 is not 100. What is it?
10.
10.
10.
Yeah, just 10. So I'm gonna fix that.
I fixed it.
Oh,
Damn.
okay, put the 0 in. All right. So again, these are the ones that I want to make sure you guys just have memorized, have them in the back of your head. That's just something that you should just kind of know. Now, it's awesome if you have them memorized. I'll be very happy if you do, but once in a while you might get a number that you don't know, right? So let me just move this. Oh no, when I move it, it doesn't move. Oh well.
Yeah, miss, we did that work, not you.
That was silly. It's okay. I'll copy down your answers. Okay.
Miss,
So the
you
thing
forgot
is,
the other fives.
sometimes you'll get a question where you don't know. You just don't. And the thing is, it's going to be helpful to know some of them because then you can estimate to the best of your ability. So let's say, for example, let me pick a number. Hold on. Okay, let's say you get on a test, right? You get, what is the cube root of 343? Now you don't know. It's not on the list of numbers that you've memorized, but we know that it's going to be something. What do you guys think? Is it going to be?
I think you would have to divide it 3 times by 3.
No, because that's not how that works. Because remember, what is the opposite of multiplying a number by itself 3 times? It's not quite what we're doing. So
Dividing itself by itself 3 times?
Right. So it would have to divide itself by 3 times, which is not an easy thing to like come up with. So what you can do is you can think, okay, the number 343 is somewhere between 125 and 1,000, right? It's in between those two values. So my answer is going to be somewhere between 5 and 10. So you can test out some numbers between 5 and 10. So we can test out 6. We can test out 7.
I believe it is 7.
Test out 8.
Because it's the lowest odd number.
Okay, so now at that point, you can kind of use your calculator, take a look, try it out. What is 6 to the power of 3? What is 6 times 6 times 6?
216.
216. So it's not that one. Now try 7. What's 7 times 7 times 7? 343. Ah, I think you were right. Right, so it is 7. That is our answer for this
Miss,
problem.
I am right though.
You were. You came up with the correct response. So that's awesome.
They're
It's like for cube roots, because you have 340, like 3 with the square root of 343, right?
Mm-hmm.
You have, I think what it means is like you take one number, you multiply, like for example, you have 7 with the exponent of 3, and you have to like see if you get that number.
Exactly. So that's why I'm saying you kind of just have to test out some values and see which one gives you the correct response. So that's basically what that is. Now let me give you one more challenge. Let's do a square root. So, oh, oops, I just deleted everything by accident. Ah.
Miss, this seems for finding out the cube root, it seems more like just intelligent guessing.
Yeah, that's basically what it is. Yeah, you're guessing, but you're checking your answer along the way. So what if you're asked for the square root of, let me think of a number. Hold on. The square root of 289. Square root of 289. So what two numbers is that maybe close to? Or what perfect squares that you know, that you've memorized, is that close to?
15 and 20.
15, right? Square root of 15 is, or not the square root of 15. The square root of 225 is 15. The square root of 400 is 20. So I know that this is going to be, whatever this is, it's going to be somewhere between 15 and 20. So now you can test out numbers. Check out 16, check 17, check 18, check 19. Which one will give you 289? I see 17, good. And when you just check those out, you just see what you get until it matches. So 16 squared is 256. Oh, Zakaya, sorry. 17 squared does give me 289, and 18 squared gives me 324. So you can figure out which one is correct by working backwards, basically. Okay.
Well, you can also start eliminating numbers by if it's even or odd.
True, true. Though sometimes you want to be a little bit careful with that because it's not, no, it will pretty much always follow the rules, but
The
if that
only
works for you, then you're good. Yeah.
The only exception would be 3. Because 3 bounces in between even and odd. That's
Yeah.
the one you have to worry about the most.
Yeah. So if you know the rules, if you're comfortable with the even versus odd, then great. But if you're not, it's a good idea to just check a few options until you find the right one. Okay. But we always know there's a but, there's always something. What happens if, let's look at these examples. They're asking us, okay, what is the square root of 32? Well, let's think about what are the closest perfect squares closest to the number 32.
5 and 6. I think I know this one. Would it be 5.5?
So let's talk about it. So we know the square root of 5, not the square root of 5, I'm so sorry. The square root of 25. We know that the number 25 is a perfect square. And we know that the number 36 is a perfect square. And 32 is just somewhere in the middle, somewhere in between those two numbers. Right? Well, like Chris said, 25, the square root of 25 is 5. The square root of 36 is 6. So we know that the square root of 32, since that's in between 25 and 36, it's going to be somewhere between 5 and 6. Right? Now, is it going to be closer to 5 or closer to 6?
Closer to 6.
Closer to 6, right? The number 32 is a little bit closer to 36. So we can estimate. We can basically make a good estimate of what this is going to be. The square root of 32. Here's a symbol. Does anyone know what that symbol means?
Rounded.
Is rounded, is approximately. It's between 5 and 6. It's a little bit closer to 6. So what is a good estimate for that value?
5.7.
Yeah, 5.7. I agree. I think that's a very good estimate.
I was thinking
So
5.75.
5.7, 5.75. Those are all good guesses. Now let's actually check to see how close we were. Do you guys know how to do the square root on your calculators or phones?
Yes.
Yeah? Does anyone need a quick demonstration? If you're using an iPhone, I can show you. First of all, you got to flip it.
Yeah, there should be a square root button on iPhone. Android, I don't know.
So on an iPhone, the square root button it does have a 2. So You'll see it on the third row. It's right here. Oh, it's kind of going to go away. It's
I
right
checked
here.
right now and it's 5.65.
So when you got to hit the 32 and then hit the square root button. And yeah, we get 5.65. So that was actually really close.
Yes, and if you round upward, it would be 5.7.
Exactly. So this was a really good guess. Good guess. Okay, let's do another. Same thing. We're estimating the square root of 50. So again, the question is, the square root of 50 is going to be between which two perfect squares? What are the
7 and 8.
7 and 8, right? Because the square root of 49 is 7. The square root of 64 is 8. So the square root of 50 is going to be somewhere between 7 and 8. But which one is it going to be closest to?
7.
Yeah, like really close to 7, right? Because it's just the next value up. So what's a good estimate for this one?
5.1 or 5.2?
Between 7 and 8, though. So 7 point.
Oh,
7.1.
oh, 7.1 or 7.2.
Yeah, 7.1, that's perfect. Because it's close. It's not exactly 7, but it's pretty close. So now go ahead and check. What is the actual square root of 50? What do you get? Using your calculators. What do you get? Square root of 50.
Oh, there's a square root on your on the built-in calculator on Windows.
Oh, cool. That's helpful to know. So you should get this really, really long decimal, right? 7.071, blah, 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 blah. But that can be also rounded up to 7.1. So again, another good guess. So that is basically how we estimate the value of a square root that isn't a perfect square. So I want you guys to try number 3. Go ahead and estimate what is going to be the square root of 72. Okay, hopefully you have a rough estimate. Now, what are the two closest perfect squares to the number 72?
9.
So the square root of 81 is 9. And then on the other side?
8.
8, yeah. The square root of 64 is 8. So square root of 72 is going to be in the middle. Is it going to be closer to one versus the other? Or is it kind of like right smack in the middle?
I think it's closer to.
I think it's closer to 64.
We'll
It's a
see.
little bit. It's like 6 units away from 64, and then no, more than 6, 8 units away, and then 9 units away from 81. So it's like it's a little bit closer to 9, or to 64, but it's kind of like right in the middle. So what's a good estimate for this one?
8.5.
8.5, yeah.
8.4.
Ooh, 8.4, 8.5. Those are both good estimates. Now, matter of fact, let's go ahead and check it. 72, press the square root button.
8.4. 8.45.
It's 8.45. So just by the nick of that tiny amount, you do round up to 8.5. But 8.44 would have also been a very good guess, a very good estimate. So any questions on estimating the value of a square root? Good, good, good. Okay. However, that's not what this question was actually asking for. So these three questions was actually telling us to simplify the square root symbol. And that's a little bit different because it's not really telling me to tell you the answer. When we simplify square roots, we want to write them in the simplest way possible. And what that means is that you're going to try and take out any perfect squares that are in that radical. So let me back up. Let me explain what I mean by that. So let's start back up with number 1. I have the square root of 32. What I'm going to do is I'm going to take 32 and I'm just going to list out the factors of 32. So what can I multiply to get 32?
You can multiply by 9.
To get 32?
Yeah.
9 times what gives me 32?
Oh, never mind. Never mind.
It's okay, not
8
9.
times 4.
8 times 4. What else?
4 times 8.
I already wrote that one down.
16 times 2.
16 times 2, good. Anything else?
32 times 1.
Yeah, 32 times 1. Okay. So there's all my factors. Now I take a look at that list. Are any of those numbers perfect squares?
No.
No.
Of these numbers here?
No. Well, 4 times 8, technically.
Not the, so the 1, the 2, the 4, the 32, the 16, the 8. Are any of those 6 numbers a perfect square?
Well, the 4 is a perfect square.
4 is a perfect square. Anything else?
The 16.
16 is a perfect square. Now, remember what that means. That means that the square root of each of those numbers is a whole number, right? That doesn't work out for 2 or 32 or 8, okay? So those are my perfect squares. Now I'm going to take the largest of those two. I'm going to take the largest one, the 16. And those are kind of like, now this is my magic number, 2 times 16. Because now I'm actually going to rewrite this as 16 times 2, right? Because 32 is just 16 times 2. So I'm just rewriting it. But then what I can actually do is I can split this up. I can write this as square root of 16 times the square root of 2. And just kind of separate them. And then what can you do? You can actually take the square root of 16. We just talked about it. What is the square root of 16?
4.
It's 4. So I have 4 times the square root of 2. And that is my simplest answer. Now, the idea behind that is that we don't want to be inside of a radical. Think of the radical as like a cage, okay? Like a little tiny cage, like it's very claustrophobic in there. So anything that can come out of the radical symbol, you want to be able to take it out. And since I can take out that 4, by taking the square root of 16, I can take out a 4. That allows me to bring things to the simplest form. So I can rewrite the square root of 32 as 4 times the square root of 2.
A way of thinking of it, like this is like the radical, everything inside the radical is Skynet, and everything outside of the radical is like John Connor's resistance. So you want to take out Skynet wants to take out everything that's John Connor has built.
Can you please tell me what 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 was that a reference to?
Terminator. You don't know what Terminator is? Miss, are there any other algebra teachers?
I'm sorry to disappoint. I'm so sorry. That is just not something I'm very knowledgeable about.
Miss,
But,
you and Miss Ardias kind of act the same.
Really? That's because we're good
Mhm.
friends. She and I are very good friends. Okay, so let's go ahead and do that now. Same idea. Let's do it with 50. So go ahead and tell me, what are the factors of 50?
25 times 2.
2 times 25. Anything else?
5
10
times 10.
times 5.
10 times 5, 5 times 10. That's it.
1 times 50.
And 1 times 50. Don't forget that that's also a factor. Okay, which of these is a perfect square?
25.
25. Perfect. Okay, so now I can go ahead and rewrite. So square root of 50 is the same as square root of 25 times 2. Split it up. And take the square root. Square root of 25, what's that?
5.
Is 5. So I have 5 times the square root of 2. And you're going to hear me say it this way. This is just how you say it kind of more quickly. Instead of saying 5 times the square root of 2, I'm just going to say 5 root 2.
Miss, where did you get that 2?
Where did I get the 2 from? Well, remember what I did was I just, instead of writing 50, I wrote it as 25 times 2.
Oh,
Okay, so I just split it into its 2 factors. So for number 2, we got 5 root 2. One more, let's do number 3, and then I'll give you guys a couple to do on your own, and then we'll be done. So 72, factors of 72.
9.
9 times what?
8.
Okay, what else?
1 times 72.
1 times 72.
4 times 18.
4 times 18, nice.
2 times 36. No.
Yeah, 2 times 36.
24 times 3.
3 times 24, good. This is one of those numbers that has like a lot of factors. So I'm gonna try and fit them all. Okay, anything else? I think there's one more that I can think of.
Oh, 6 times 11.
6
No,
times 12.
12.
12. Good. Okay, so there's all my factors. Do I have any perfect squares in there?
36.
36. There's a few actually, so what else?
9.
9.
9. And I see one more.
24.
4.
4. Not 24. Because again, you can't take the square root of 24 and get a nice whole number.
It would be
It'd be like
24 is 1
4.9.
off of 25, so it would be 4.9.
Yeah, about 4.9, yeah. Okay, so then again, you pick the largest one. Always go with the biggest one. And then we can go ahead and do the problem. So 72, split that up. That's going to be 36 times 2. Square root of 36 times the square root of 2. What is the square root of 36?
6.
6.
6. So this is 6 root 2. All right. So questions now before I give you a couple to do on your own. Okay, cool. Here they are. We have perfect amount of time remaining, so go ahead and take about 2 to 3 minutes and try these out. So when you're doing these, I don't want you to estimate the answer. I want you to simplify it. So it should look kind of like what we got here. Okay, just clarifying. About 30 seconds remaining. All right, time is up. So let's go ahead and take number 11. Number 11, what two factors can I split this up into, the number 12?
9 and 16.
Factors.
3 and 4.
3 and 4. Remember, factors have to multiply to make 12. So we're thinking about numbers that multiply and make 12. Now, 3 and 4 is perfect. Why is 3 and 4 better than 6 and 2? Why do we choose 4 and 3?
Because 4 is a perfect square.
Because 4 is a perfect square, exactly. Because now I can write square root of 4, square root of 3. I know the square root of 4 is
2.
is 2. So this is 2 root 3. We just say 2 root 3.
Workers kept showing me
Now, there was a couple of questions in the chat I want to clarify. Because at this point, you could take your calculator out and do it and say, okay, what is the square root of 12? Let's see. Square root of 12 is 3.46, what is this? 3.4641016151377755, and it keeps going past that. We're going to talk about this maybe on Thursday, but basically the square root of 12 is what we call an irrational number. Irrational numbers are decimals that go on forever, forever and ever and ever. Here's one behind me, pi is an irrational number. So when I want to know the answer, like if I'm asking you what is the square root of 12, and I'm asking you to simplify it, I can't just sit here and write the numbers 464101615 13775. Is that simple? Is that simplified?
No.
It's not very simple, right? So writing it the way that I've written it as my final answer is just a simplified way of writing the number without giving the actual answer. So it's kind of weird. Like, I know it's a little bit weird to get used to, but that is the difference between simplifying the answer and estimating the answer, which is what we were doing before. So we're just rewriting it a different way. That's all it is. Okay, so yeah, I'm not giving you the actual answer to it. I'm just rewriting it a different way.
Miss, how do we put that? How do we put the answer in chat?
Ooh, good question. If you're trying to just do the square root symbol, you can do, here, let me type it to everybody. So a good way to kind of fake that symbol is to do the dash and then the slash, like that. So that if you want to write like the final answer, you can write, for this one, it would have been 2 root 3, like that. Okay. Number 12, 75 splits up into what and what?
3 and 25.
3 and 25. And that's a good option because, again, 25 is a perfect square. All right, so then this is the square root of 25 times the square root of 3. What's the square root of 25?
5.
It's 5. So I get 5 root 3. 5 root 3. And that is that. So kind of one of those things that, like I said, it's just something new to get used to. However, what I do want you guys to do, if you didn't do it yesterday for Khan Academy, I'm going to repost it on Khan Academy, just one assignment. It's just this. And it's going to be good practice to understand how to simplify these types of radicals. So I'm
Is
going
it
to,
for free?
I was just going to say, I will make it extra credit. So it's not required, but I will make it extra credit if you get that done. And if you already did it, guess what? You already have the extra credit. So good job if you've already done it, if you did it yesterday. But I'm going to reassign it right now on Khan Academy for anyone who didn't do it already. So any final questions before we get out of here?
No.
All right, guys.
Why wouldn't you do my project?
We'll talk about that later, Chris. Chris is trying to get me to watch all the Terminator movies. Do you guys think I need to do that?
Yes. This
No.
was